Hello, everyone. Today we're going to learn about the difference between intra and intermolecular forces. Our focus here is oops, forces of attraction. What evidence is there that the force of attraction between items of clothing removed from the dryer is electrical in nature? When you first take stuff out, and maybe socks or other particles are stuck to it, when you separate them, you'll hear those sparks or static noise. Um, then, what evidence is there that the force of attraction exists between atoms or molecules? Um, Now, when we have a solid, uh, it takes energy for it to break that. It doesn't break on its own. So maybe heat is required to melt it. Um, And if we have liquid, for example, it stays together in a glass, and once you start to heat it, then it starts to evaporate. It's one way of looking at it. So we're going to describe the difference between intramolecular forces and intermolecular forces. And one review of vocab is polar covalent. It's a type of bond that's formed when electrons are not equally shared. So this is a type of covalent bond, not equally shared, is polar. We have one side is slightly positive and one side is slightly negative. Now, when it comes to intramolecular forces, this is a review from our first semester when we learned about ionic, covalent, and metallic. Ionic, when we have cation and anion, that's metal and non-metal. One loses, one gains, and they form an attraction. Covalent sharing of electrons. And metallic is when we have all metals and they form this sea of ions or sea of electrons between them. That's why it conducts. So this is the type of intramolecular forces. So it's between it's that what holds the molecules together.
Dispersion forces. The weak forces resulting from temporary shifts in the density of electrons in electron clouds.
Now, briefly, when we have this polar, where one slide is positive, one slide is negative, eventually realign themselves and they're attracted, the positive attracted to the negative, but it's temporary. It's not very long time. So it's not as strong as the ionic or covalent, but this is just for brief period of time. They realign, they have attraction, and then they go their own ways.
Dipole-dipole forces. The attractions between oppositely charged regions of polar molecules.
Okay, so this is what's called intermolecular. So it's between molecules. Eventually, that slightly positive attracts the slightly negative, and they form that net of attraction. Okay.
Hydrogen bond. A strong dipole-dipole attraction between molecules that contain a hydrogen atom bonded to a small, highly electronegative atom.
So one type of the dipole-dipole, which is slightly positive and slightly negative polar compounds, is an atom molecules that contain a hydrogen and um, a highly electronegative. Usually, it's fluorine, oxygen, or nitrogen. This we call this hydrogen bond. So this is also intermolecular forces. Another example would be water. Um, it has hydrogen and it has oxygen. So this it has a hydrogen bond, and they form this uh, connection between all molecules. Intermolecular forces between water molecules. Hydrogen attract the oxygen, and so on. Now, now, of course, you could see methane and ammonia. They also have hydrogen in them, but it's not the same. It has to have hydrogen bond is hydrogen with oxygen, nitrogen, or fluorine. And you can see this by the boiling point, which is the energy required to break the bond. We were saying that it requires high energy when it's high electronegative atom bonded to hydrogen versus methane, which is very negative. It's negative 33.4, and versus ammonia, which is negative 164. So hydrogen is stronger when it's with high electronegative atoms. Okay, that's it for our video today. It's inter versus intramolecular forces. Thank you guys. We'll see you next time.